Hello students, today we are going to teach vertical circular motion. Yesterday we have discussed about the vertical circular motion, the velocity at different points, different positions in vertical circular motion, and formula is at lowest point velocity Va, and at any point related to Va, lowest point is Vp is equal to root Va square minus 2gh. तो यदि हमको लोएस्ट पॉइंट पे वेलोसिटी पता है तो हम वर्टिकल सर्कुलर मोशन के किसी भी पॉइंट पर वेलोसिटी को कैलकुलेट कर सकते हैं। आज हम फॉर्मूला डिराइव करेंगे टेंशन इन स्ट्रिंग एट डिफरेंट पॉइंट्स इन वर्टिकल सर्कुलर मोशन। This is A point and velocity at this point is Va. This is P point. This is P point. Tension nesting towards the center, that is T. Mg, M is the mass of the body. This angle is theta. This angle also will be theta. This is mg cos theta. Here velocity Va, and at P point velocity will be Vb. At point P, T minus mg cos theta is the resultant force, and it is equal to the centripetal force mvp square upon r. Now T will be equal to mg cos theta plus mvp square upon r. T is equal to mg and this is n point cos theta from triangle ONP, base upon hypotenuse. It means n upon OP plus m upon r, and Vp square is Va square minus 2gh is equal to mg on is r minus h upon r plus m upon r Va square minus 2gh is equal to m upon r कॉमन लेंगे gr minus gh plus Va square minus 2gh. General formula of tension in string will be T is equal to m upon r Va square minus 3gh plus g. This is the general formula of tension at any point P in the string. यदि हम वेलोसिटी को कम करते जाएं वर्टिकल सर्कुलर मोशन में, तो एक पोजीशन हमको ऐसी मिलती है जिस पर की टॉप पॉइंट पर, जो हाईएस्ट पॉइंट है, उस पर टेंशन जीरो है, एंड body is able to execute the vertical circular motion at that tension also. So this minimum tension, this minimum velocity is called critical velocity for that point. The minimum velocity at any point for which the minimum velocity at any point for which body execute the vertical circular motion is called critical velocity for that point. It is fixed for any point but remains different for different points. ये हर पॉइंट के लिए अलग अलग होगी लेकिन उस एक पॉइंट के लिए पर्टिकुलर होगी उतनी ही होगी हमेशा कांस्टेंट रहेगी बट अलग अलग पॉइंट्स के लिए डिफरेंट डिफरेंट होगी फॉर दैट मिनिमम वेलोसिटी बॉडी विल एग्जीक्यूट द सर्कुलर मोशन this is lowest point A, B, C and D. At the time of critical velocity, it means the lowest velocity, the tension at C will be equal to 0. So that Tc is equal to m upon r Va square minus 3g, and at for C point h is equal to 2r plus gr. It means Tc is equal to m upon r Va square minus 5gr is equal to 0, and Va square will be equal to 5gr and Va is equal to root 5gr. This formula is the critical velocity at point A. Tension at C is 0 and critical velocity, the minimum velocity to execute the vertical circular motion required at point A will be root 5gr. Tb is equal to Tc is equal to m upon r. Va square means 5gr. Va square minus 3gh plus gr. Put the value of Va square, it means 5gr minus 3g. Here h will be equal to r plus gr. 6gr minus 3gr upon r, it is equal to 3 mg. Tension at B is equal to tension at C will be equal to 3 mg. Velocity at B and C will be, we know that VB is equal to VC is equal to root VA square minus 2G and H is equal to R. It is 5GR minus 2GR, that is root 3GR. VB is equal to VC is equal to root 3GR. In critical situation, velocity at B and C will be root 3GR and tension is 3 mg. At lowest point, what will be the tension at A? That is TA is equal to M upon R VA square minus 3G, H is 0 here, plus GR, that is M upon R 5GR plus GR, that is equal to 6 mg TA. So we conclude these results in vertical circular motion. For a critical velocity means minimum velocity for which the body will execute the vertical circular motion are as follows. Tension in string, .8 A. Tension is 6 mg. M is lowest point and velocity VA is equal to root 5GR. 8 point B and D, TB is equal to TD is equal to 3 mg, VB is equal to VD is equal to 3GR, and at highest point 8 point C, TC is equal to 0 and VC is equal to root GR. Here A, B, C are the points. This is point A and this is B and this is C and this is D. This is lowest velocity at each and every point. At lowest point, lowest velocity to execute the vertical circular motion is root 5GR, and lowest velocity required at point B and D will be root 3GR, and at the highest point required velocity is root GR. If velocity is less than this, the body will not execute the vertical circular motion. यदि वेलोसिटी इससे कम होती है तो बॉडी वहां से ड्रॉप करेगी कहीं से भी और सर्कुलर मोशन कंप्लीट नहीं होगा वर्टिकल सर्कुलर मोशन। और जब ये सर्कुलर मोशन करती है मिनिमम वेलोसिटी से तो डिफरेंट पॉइंट्स पर टेंशन क्या होगा वो हमने निकाला. At highest point tension will be 0 and TB and TC 3 mg, and at lowest point because velocity is maximum so tension is also maximum, it will be equal to 6 mg.